Hello and welcome to another episode of Cavell Cloud Conversations. I'm Finbarr, Senior Research Analyst at the Cavell Group. Exciting episode for you today covering all things cloud networking. So if you don't know what those are and you're kind of curious, stay tuned. Really great episode for you today. Alright, so cloud networking. By the way, this is my area of specialization. I am the research analyst at Cavell, tasked with studying the networking and cloud networking areas. So, you are getting this information right from the source, from someone who spends all of their time looking at it. What do we mean when we're talking about cloud networking? Overall, cloud networking is a broad trend that deals with the fact that a lot of applications have been moving to the cloud. What is the cloud for the uninitiated? It is the broad network of data centers, hosted services, and virtual applications that make up this idea of a cloud of computers. So something like your Microsoft Teams, your Office 365, your Amazon Web Services, all of those are hosted in this theoretical idea of a cloud, right? We talk about cloud computing, that's what we're talking about. When we're talking about cloud networking, really what we're talking about is the hosting of software functions in the cloud, so on virtual machines, on hosted platforms, and then the delivery of more flexible than previous generation generic hardware that is capable of doing more, being controlled remotely from the cloud by that cloud function. So similar to the idea of software-defined networks, where a lot of the previously, we'll say, rigid network functions on hardware were slowly converted over to software-defined networking functions, and all these network functions were virtualized. NFV functionality happened. We see a similar trend happening in WANs, in more computer networks, really to respond to the trend that a lot of businesses are having to deal with more cloud applications built into their network. Therefore, they need a more cloud-focused approach at dealing with cloud solutions, because if you're trying to get to cloud applications, what you really need to do is have a smarter network that's better at getting to cloud applications and optimizing them. This previous model where we have everything routed through a corporate data hub and all those other kind of platforms just really isn't the sort of solution that we need for a cloud sort of environment, right? So the primary focus, I guess, of cloud networking comes under two technologies, which we'll talk about today. SD-WAN, so software-defined wide area networking, and secure access service edge, SASE, or cloud delivered security. So we're going to get into those in a second. Just to say at the start, something for you all to think about, that obviously as a research company, we do actually produce research on this area. So this is something you're listening to and you're thinking, actually, I'm going to listen to this as an introduction, but I really need to know a lot more about this. I have recently just finished a research paper on the SD-WAN market in the UK. It costs about, I think, $2,500, but it's about 55 pages. It goes through all of the vendors, what they're doing, what the channel says about them, how the market is selling them in the UK and in Europe, how people are bundling it, how people are marketing it, where they're seeing success, where the future trends are, where the MSP strategy falls in, where the pitfalls are, all of those kind of like real sort of market addressable advice and guidance, coupled with like a projection of where the market stands in the UK from the total addressable market, but also including something like an estimate on the market size. So if that's something you're interested in, you can just go to our website, talk to the chatbot. That email will come to me, or email me at finbar@cavellgroup.com. We can have a discussion, and of course the research does come with consultation time and a call with me to run through it, and just generally a discussion. There is also another enterprise focused piece coming out in Q3, late Q3, early Q4, where we're going to be looking at the enterprise and how the enterprise is doing networking, which will be a survey of network decision makers on the enterprise IT side. So if those sorts of things are interesting to you, and we do bespoke research projects as well, do just get in touch. We have helped a lot of people with strategy. Now I'm done selling. I have to do it. It's very important. Let's talk about what we're actually talking about. So SD-WAN is something that's been around for a few years, but it is starting to grow. It is starting to see a rise in penetration. And essentially, there are many ways to break down how you can think of SD-WAN. I think the easiest way to approach this for people who aren't as familiar with what it is to think of it as a new type of router that has a cloud management platform attached to it, and probably comes with more capabilities for managing and controlling the network than the routers you had previously, right? And that's an oversimplification, but so really what we're talking about is replacing those edge premise devices that do just one task with more flexible devices that are capable of doing multiple features, as determined by the software that's installed on them. Right, so what does that sort of mean? It means that, to an extent, we are talking about new functionality, but a lot of the time we're not. Really, it means that stuff like WAN optimization, so this is a sort of, forward error correction, compression, bandwidth management, all those kind of things that companies like Riverbed and Silver Peak would have done for a long time are now being built into flexible software platforms that are, capable of doing more than one feature. Also, we're seeing stuff like bandwidth aggregation, link bonding, all of these kind of tools to make use of more than one link at your company, make use of multiple types of bandwidth at your company, including like application prioritization and stuff like that make sure that the right application is using the bandwidth at the right time. Like, you don't want your backup, say, running when everyone is at the busiest point of the day trying to use their phone calling to get sales done. You want it running when people start to leave the office or at night when no one's there, and it can have the full link that you have available at your site. So we're starting to see all of these older technologies being incorporated and made into software-defined platforms. That, of course, brings with it a lot of confusion, because a lot of companies that did simplistic networking are now calling themselves SD-WAN because they have a central management platform. I think it's very important for people who are listening to this who don't know much about the marketplace to understand that the question doesn't stop when someone says SD-WAN. It's not like 5G. It's not like a simple explanation. It's like, oh, what do you do? Oh, we do SD-WAN. It is a case of, okay, so what does that mean? What features are you actually offering me that distinguish? There is no real standard. Despite people's attempts to make one, there isn't really a standard for what SD-WAN means or anything like that. So really it is a question of digging a little deeper when people use those words. But at a high level, replacing of routers and edge devices with more flexible devices that can be managed centrally from the cloud. Now, what's important here, and it's kind of important to our second discussion, which is going to be about security, is that one of the primary things that this is leading to is a lot more data generation on the networking side, right? So before it was a case of, does the device work? Does it do what it does? Okay, maybe I can go on site and collect the data. And now we're very much in a situation where it's a case of the data is always being fed back into this central platform, and this central platform then understands who's doing what, how are people doing it, is this operating? Is this doing what it should do? Are there any errors happening in real time? How do we process those errors, right? And that data is then being used not just for analytics and ongoing management, but also by some of the SD-WAN companies for real-time problem solving, diagnosis, and also to point the engineering teams in the right direction so that they know where the problem is, right? So you can imagine, and if you think about the big SD-WAN companies who are doing this, you've got Cisco doing this, VMware doing this, you've got Juniper Mist especially, they're focusing on it quite a lot, to build these automated systems that are better at dealing with networks and better at addressing network problems. And one of the things that Juniper is working on, is quite interesting, is this natural language feature for engineers to use to interact with their network platform, which means rather than coming in the morning and trying to figure out where the errors are happening based on the problems that have been reported, you just type into this natural language processor, what errors have I seen on X overnight? What errors do I need to address? What are the serious critical issues? And you'll get responses back that are understandable and give you a pathway to action. So the fact is that, we're not quite at the point of automated error correction on networks. We are at the point where data can be used to point people in the right direction to solve errors faster because they know exactly where the error is. You have to forgive me, every so often that happens. So if you can tell, I've got someone in the background and they're sitting in their car and periodically they're putting their car alarm on. I have no idea what's going on. So apologies for the interruption, but we're going to keep throwing through this episode because I'm on a nice bit of a roll. And that just helps you understand that these episodes aren't highly edited. They're not highly polished. We are here to provide kind of like a casual, conversational, bit of a fun narrative. And if there's occasionally a little interruption from real life, then that's perfectly fine with us because we want them to be enjoyable. We are just people like you. And there is also this concept that, often in our industry, especially with analysts, that these podcasts become a bit too polished. They become a bit too, not real. People are just using them for marketing rather than actually talking on them and actually having real life conversations about what this technology means. And one of the reasons that I'm so fascinated by all of this software defined networking is just this idea that as cloud applications get so complex, there is no solution other than to automate. And then it becomes a question of how much can we automate? How optimized can we make things? And I'm just looking at this from a situation because I play games a lot in my spare time. And one of the things that keeps happening is I have amazingly good latency compared to, say, 10, 15 years ago when I was a kid, where I'd have like 200 ms. There's not a lot of latency, but now I have like 12 on the regular. And, the applications of this for business are obviously huge because error correction, keeping sites online, if a retail store goes down and we can get that back online straight away, that represents a good amount of missed sales opportunities. There's lots of businesses that just need to be online all the time to mitigate risk and to do all these other things. But, the fact is that all of these technologies, when they become super advanced, actually spill out of the business world into the consumer world as well, and have the premise and the idea that they're going to eventually affect all of our lives. So we're all operating in this sort of automated, self-correcting network environment. Now, but data is an interesting thing, and it kind of leads us into our next discussion, which is security, because data is very, very important for the security discussion on the networking side as well. Before I talk about that, let's just quickly define the playing field, because not everyone is familiar with either what we're talking about or the need for what we're talking about. So what we're talking about on a basic level of cloud delivered security is this idea that if you are getting all of your cloud applications as an end user, then you need the cloud applications to be secure while you're accessing them. And then you kind of need security hosted alongside those cloud applications to make sure they're secure when you get them back, or when you interact with them. I mean, you combine that with the trend from the past few years where we've got COVID happening, everyone working from home or working remotely, and you kind of have a situation where the access profile of companies has changed drastically. It's no longer person sitting in office behind corporate firewall. It is person sitting at home, in an airport, on a beach, trying to access the cloud, trying to access cloud applications. And if that person then has to route through a VPN into their corporate data center, and then that corporate data center has to access the cloud that their systems are now hosted on, that person is going to get a huge amount of latency, right? Which is going to cause a very negative experience and take a long time for their files to download, make collaboration difficult, and all of these problems. So the solution a lot of companies are trying to find and figure out is how do we get that user to access the cloud applications they want directly. Now, obviously it makes sense. There are, for the bigger cloud applications, a lot of the big cloud application companies have gateways. The gateways are basically just internet-facing sites that if you know the IP for, you can dial through and it's going to connect into their data center. So basically allowing for people to connect from the internet into their service, which means that often the fastest route from remote employee A to cloud service B is just to go directly over the internet to that cloud service and not go through a VPN to a corporate data center, etc. However, that being said, that is not secure. So that's why you've seen the rise of a lot of secure access solutions, like Zscaler has one, for example. Palo Alto has Prism Secure Access. All of these solutions are basically here to try and connect the end user to the solution in a secure way, bypassing corporate data centers, but getting that user securely from wherever they are, if that location is secure enough, to the cloud service. And that becomes more and more important, and the kind of risen rise to this trend of cloud delivered network security, also called SASE, Secure Access Service Edge. The idea being you're securing the access place that the person is accessing from, or the service edge, as in wherever the service ends, that's the service edge, and you want to secure access from the service edge all the way to the cloud. Now, obviously this is vitally important for remote workers and companies, but it's also something that incorporates things like SD-WAN, right? SD-WAN is actually a feature in SASE, and the point really we're trying to get to is that we are going towards a joint paradigm where security and networking are combined, so that the network is being optimized by one program on your laptop, security is being handled by another program. They work together. They create a joint database of shared information that says exactly how they're operating, and then they push forward together to deliver you the most optimized, secure route to the cloud service from wherever you are, right? And that's really, I think it's an ideal dream if it can be realized. And some companies are further along towards realizing it than others, though really a lot of what is happening at the moment is that people still need security devices and network devices to truly realize the benefits of SD-WAN and SASE, which means that most people aren't getting those benefits, right? Most people are getting a VPN on their computer, a cloud VPN, and some form of secure access protocols. That's what the average employee at we'll say a large company is getting. Super serious employees at those large companies might get, more protection, might get a home access point that has a mini firewall and some SD-WAN features on, so that they have guaranteed uptime. They might even get a second link into their house, but the majority of people aren't getting that because it's still too expensive. They're getting a software solution. But, you might be thinking, okay, it's too expensive, but you still think we're going to get there. And why do you think we're going to get there? See, I'm filling in Patrick's role. I'm basically asking myself questions because he's on holiday. And why do I think we're going to get there? The answer is very simple. We have to. For security reasons, we have to get there. And we have to get there as well because of the data gathered by these platforms is non-negotiable from a security perspective, right? So if you look at security research and maybe some, and I recently looked, I think it was a Checkpoint survey that just said, that 60% of attacks were going to be manual. The very fact is that the database method of identifying threats and dealing with them really does struggle when you have manual attacks or authentication-based attacks where someone gets access to someone's credentials. Because really what those systems are looking for says, okay, here's a malware, here's an exploit, X, okay, we've seen that on the system, block that, stop it from happening, right? And that's same with sandboxing and all those kind of things. Whereas if someone actually gets user credentials via some sort of social campaign or that kind of, social engineering, once they get access to someone's email or something like that, then it becomes a really big problem. The only way really to spot it is to have sufficient data on the behaviors and movements and patterns of access of your employees to really see when something strange starts to happen. So that's where this data convergence between security and networking becomes super important for the security of large companies. Because if you think about what companies like Darktrace, who I would look up, are very interesting, have been doing for the past few years, we're really seeing a situation where they're taking data to generate a user profile that defines how someone acts. So, really is the case of, okay, Finbarr has not ever accessed the account system on Cavell. It's not true, I have. But, for example, say I work in research and I've never done any accounting at all at my company and I've never filed an expense. And suddenly I go in and I'm starting to download all the accounts from the past 5 years to try and figure out how much money Cavell's making. Or I'm, going into all of our systems to try and figure out where I can get an admin account and something like that. The second I start to do that, if my network is generating data about where I'm going, suddenly it creates a pattern profile that can be stopped automatically. My network, my device can be kicked off the network if we're really sensitive, or it can just be flagged for IT for investigation, right? So in that way, the network data that we've been talking about earlier, combined with the security functions of the cloud delivered security and ongoing analytics, and all centrally managed, so this is all visible from one hub, come together to sort of create a more secure and more efficient security and network operation that works together. And that's really where we're going, and that's really where this stuff sort of gets interesting in the next couple of years. Of course, at the moment, it's a bit tricky because it's only really your high-value workers that are getting that, level of protection, unless you work in some super serious regulatory industries. Because a lot of this technology still just requires a device on the edge of the network, so an access point or some sort of tool, firewall, that kind of thing for securing stuff. So without that device, which is still costs a lot of money, the features are limited, though there are some software capabilities. Anyway, that's it really. I'm going to wrap up there. I hope you found this interesting. We are returning to the topic of cloud communications next week. We will also have several other companies joining us over the next few weeks. We have some of the companies we work with and our sponsors for the upcoming CloudComm's USA event that we host in Chicago in October. So if you're near Chicago and you want to come to that, just search for the CloudComm Summit USA, which we're running in conjunction with the Cloud Communications Alliance of the CCA in the US. We'll have some of the sponsors from that coming in to do episodes with us. They will still be conversational. We're not just going to let them come on and push marketing. We're going to have a nice chat about what they're up to and the future of technology. You should find it really interesting. So stay tuned for those. And of course, if you've enjoyed listening to these episodes, please do, give us a review, give us a like, or just get in touch and let us know what works for you and what doesn't. As a company, we really want to start sharing our expertise and getting you guys interested in our findings beyond just, people who subscribe to our research and those kind of things, and really do lead some discussion in this. But obviously, discussion works best when it is both ways. So please do get in touch if you have any thoughts to share with us. A few of you already have, and we're really appreciative for that. And you've let us know you've been really enjoying the conversational tones of the episodes, how fun they are, and still learning a few things as well. So thanks so much for that feedback. It's been really good. The whole team has really enjoyed getting it, and we'll all speak to you soon. Thanks and bye.